Hello students, how are you? I hope all of you are good. So in this video, I am going to start the introduction part for the second exercise of the chapter 3-dimensional geometry. So I am going to discuss what? Introduction part for the exercise 11.2. Introduction part for the exercise 11.2, and introduction part of this exercise consists totally three concepts, and in that the first one is equation of line. And basically we are going to study in 3D, that is what? Equation of line in space. And the second concept is angle between two lines. Angle between two lines. So we need to study the concept what? Angle between two lines. And the third concept is shortest distance between two lines. Shortest distance between two lines. Shortest distance between two lines. So these are the most important concept required to us to solve the questions from the exercise 11.2. So without wasting the time, let's start the first concept. What is the first concept? Equation of line. The first concept is what? Equation of line. First concept is equation of line. Equation of line. And to identify the equation of line, he has to give two conditions here. And that condition is, in that the first condition is equation of line passing through the given point. Passing through the given point. Equation of line passing through given point. Passing through given point. And the second condition is parallel to a given vector. And parallel to a given vector. And parallel to a given vector. Parallel to a given vector. So we need to identify the equation of line which passes through one point and parallel to one of the vector. So see here, and we need to write the equation of this line in vector form as well as in Cartesian form. So vector form means the equation involving the vectors, and Cartesian form means the equation involving Cartesian coordinates x, y and z. See here the required line is passes through given point. It means he has to given one of the point, and parallel to the given vector. It means he has to given one of the parallel vector to the required line. See here, let this is the x-axis, y-axis and z-axis, which is the origin. So here we need a line. Suppose this is a line, and he has to given one of the point on this line. Let's say this is a point, and also he has to given one of the parallel vector, that is what? B vector. So here the parallel vector is B vector. Parallel vector is also known as direction vector. Parallel vector innondu ಹೆಸರೇನು? Direction vector. See here, now we need this line, that is what? L line. So what is the equation of line? So basically this line is passes through the point A and parallel to the vector B, and the coordinates of this given point is, A is x1, y1 and z1, and the direction ratios of this parallel vector, direction ratios of parallel vector B vector is equals to A, B and C. So now we need the equation of the line L. So direction is similar to the parallel vector, therefore direction is similar to B vector. And if we have a line, it may be any line. So if we have a line L, on that line we have one of the general point, that is what x, y and z. As we change the values of x, y and z, we are going to get the different points on the line. So it means on every line we have one of the general point. So let us consider the general point is P on the line L, and let the coordinates of the general point is always what? X, y and z. So see here, to identify the equation of line L, equation of line L. So A is a point on the line, and we know that position vector of the point A is OA vector. Position vector of the point A is OA vector. So direction from O to A. And position vector of the point P is OP vector. So that is direction from O to P. And let us define position vector of the point A. OA vector is equals to A vector. Position vector of the point A, that is what? OA vector is equals to what? A vector. So position vector of the point A is OA vector, which is defined by what? A vector. And the position vector of the point P is OP vector, which is defined by R vector. So let the position vector of the general point OP vector is defined by what? R vector. Now observe this diagram. OAP is one of the triangle, and from the triangle law of vector addition, from the triangle law of vector addition, from figure, from figure, using what? Triangle law of vector addition, vector addition, vector addition. See here, OA vector plus AP vector is equal to R vector or OP vector. From the triangle law of vector addition, we may write it as in triangle OAP, OAP, by using the triangle law of vector addition, OA vector plus AP vector plus AP vector is equal to R vector, is equal to R vector. R, OA vector is equals to A vector. So A vector plus, see here, AP vector is parallel to B vector. So from the figure we know that AP vector is parallel to B vector, is parallel to B vector. AP vector is parallel to B vector. It means since AP vector and B vectors are parallel, it means they are collinear. And from the condition of collinearity of any two vectors, we may write it as AP vector is equals to lambda times of B vector. Therefore, this equation R vector is equals to OA vector plus AP vector can be written as A vector plus lambda times of B vector is equals to R vector. And this is what? Required vector equation of the required line. So what is this? R vector is equals to what? A vector plus lambda times of B vector. And this equation is what? Vector equation. Vector equation of the required line. Vector equation of the required line, where a vector is, where a vector is position vector of the point through which the given line is passing. So a vector is position vector of the given point. So therefore a vector is what? Position vector. A vector is what? Position vector. A vector is position vector of position vector of point through which through which through which through which required line is passing. Required line is passing. I hope all of you understanding. And what is this B vector? And what is this B vector? B vector is a parallel vector of the required line, or direction vector of the required line. What is B vector? Parallel vector, or in other words we may call it as direction vector. Direction vector of the required line, direction vector of the required line. And what is this r vector? R vector is position vector of general point, position vector of general point on the line. So you should know all these three things, then only we are able to solve the problems. In vector equation we have three vectors. First one is r vector, a vector and b vector. So where r vector is position vector of the general point on the required line, and a vector is position vector of the point through which this required line is passing, and b vector is a parallel vector of the required line or direction vector of the required line. So we got the vector equation of the line. And what is the next one? We need its Cartesian equation. Cartesian equation means equation involving the Cartesian coordinates. That is what? X, y and z. And one more thing, for writing the Cartesian equation of the line, see here the coordinates of the point A is x1, y1, z1. It means its position vector. It means its position vector is a vector. And a vector in component form, we may write it as x1i plus y1j plus z1k, and position vector of the point P is r vector, and its component form is xi plus yj plus zk, and also direction ratios of b vector is abc. It means component form of b vector is ai plus bj plus ck. I hope all of you understood. For obtaining the Cartesian equation of this required line, use the values a vector, r vector and b vector in its vector equation. See here, ಸ್ವಲ್ಪ ಪ್ಲೇಸ್ ಬೇಕಾಗುತ್ತಾ ನೋಡೋಣ, ಟ್ರೈ ಮಾಡೋಣ. See here. So here r vector is, I am going to substitute the values of r vector, a vector and b vector in first equation, where first equation is vector equation of the line. So for Cartesian equation, use r vector, a vector and b vector in the first equation. Therefore first equation implies, so r vector is xi plus yj plus zk equal to a vector is x1i plus y1j plus z1k plus lambda times of b vector, where b vector is ai plus bj plus ck, ai plus bj plus ck. Now see here, from this equation, so left side xi plus yj plus zk as it is, and shift this x1i plus y1j plus z1k to left side. It becomes what? Minus x1i minus y1j minus z1k equal to lambda ai plus lambda bj plus lambda ck. Now see here, on left side xi minus x1i can be written as x minus x minus x1i plus yj minus y1j can be written as y minus y1j plus zk minus z1k can be written as z minus z1k equal to lambda ai plus lambda bj plus lambda ck. I hope all of you understanding. Now see here, on left side we have one of the vector is of the form, ಸ್ವಲ್ಪ ಇಲ್ಲಿ ನೋಡ್ರಿ ಏನು ಮಾಡ್ತಾ ಇದ್ದೀನಿ, z minus z1 times of k. So here on left side we have one of the vector in ijk form, and right side also we have one of the vector in ijk form, and both the vectors are related by the equality sign. It means from the definition of equality of two vectors, corresponding coefficients of I, j and k are also equal. By comparing these two vectors, we got what? x minus x1 is equals to lambda a, that is nothing but coefficient of I in left side is equals to coefficient of I in right side, and coefficient of j y minus y1 is equals to lambda b. Similarly, z minus z1 is equals to z minus z1 is equals to lambda c. I hope all of you are understanding. Now see here, from these three equations, ಇದು ತೆಗಿತೀನಿ ನೋಡ್ರಿ ಸ್ವಲ್ಪ. See here, from these three equations, we may write from these three equations, we may write first x minus x1 is equals to lambda a can be written as x minus x1 divided by a is equal to lambda anta baribodu nodri. And from the second equation, that is y minus y1 equals to lambda b can be written as y minus y1 divided by b equal to lambda anta barkobodu. And similarly, from z minus z1 equal to lambda c, we may write it as z minus z1 divided by c is equals to lambda. Now observe these three equations, x minus x1 by a, y minus y1 by b, and z minus z1 by c, all are equal to lambda. It means they are equals to each other. If these three quantities are equal to lambda, then definitely all of these three quantities are equals to each other. So it means finally we got x minus x1 divided by a equal to y minus y1 divided by b equal to z minus z1 by c, where x1, y1, z1 are the coordinates of the point through which the required line is passing, and x, y, z are the general point on the required line, and a, b, c are the direction ratios of the parallel vector. So to solve the problems, we need to know what are the x, y, z, x1, y1, z1, and a, b, c are in this equation. And this equation x minus x1 by a, y minus y1 by b, z minus z1 by b is known as Cartesian equation of the required line. Cartesian equation of the required line which passes through the given point A and parallel to the given vector B. Where, so barita idini nodri, because these things are important to solve the problems. Where what is x, y, and z? X, y, z are coordinates of what? Of general point on the line, and x1, y1, z1, x1, y1, z1 are what? Coordinates of point through which required line is passing. And ABC A, B, and C are what? Are direction ratios of parallel vector. Direction ratios of parallel vector are direction ratios of direction vector. I hope all of you understood. Equation of line passes through the point and parallel to the vector, their vector equation and Cartesian equation. So vector equation of the line passes through the given point and parallel to the given vector is r vector is equals to a vector plus lambda times of b vector, where a vector is position vector of the point through which the given line or required line is passing, and r vector is the position vector of the general point on the line, and b vector is parallel vector or direction vector of the required line. and the Cartesian equation of the line passes through the given point and parallel to the given vector is x minus x1 by a equals to y minus y1 by b equal to z minus z1 by c, where x, y, z are the coordinates of the general point on the required line, coordinates of the general point on the required line, and similarly x1, y1, z1 are the coordinates of the line or coordinates of the point through which the required line is passing, and ABC are the direction ratios of parallel vector or direction ratios of the direction vector. I hope all of you understood this thing. So let's start the second topic, that is what? Angle between two lines. So now the second concept is what? Angle between two lines. Angle between two lines. Angle between two lines. See here, we need to identify the angle between two lines. So let's see. Let's suppose he has given one of the line and this is the first line, and this one is the second line, this one is a second line, and this is the angle between these two lines, first and second line. So, and as you already know that vector equation of the line is r vector is equals to a vector plus lambda times of b vector. So it means if this is a first line, definitely for this line we have one of the parallel vector, and let's say it is equals to b1 vector. And for the second line also we have one of the parallel vectors. Let's say this is equals to b2 vector. So first line and second line, their intersection, and theta is the angle between these two vectors. And for every line we have one of the parallel vector. So b1 vector is the parallel vector of the first line and b2 vector is the parallel vector of the second line. And equation of the first line is r vector is equals to a1 vector plus lambda times of b vector or b1 vector, where a1 vector is position vector of the point through which the first line is passing and b1 vector is parallel vector of the first line. Similarly, the equation of second line is r vector is equals to a2 vector plus mu times of b2 vector. So lambda and mu be any constants or any non-zero scalars. So second equation, r vector is equals to a2 vector plus mu times of b2 vector is equation of second line, where a2 vector is position vector of the point through which this second line is passing and b2 vector is parallel vector of the second line. Now we need to identify the angle between these two lines. So angle between these two lines is theta. It means from the corresponding angles, angle between two vectors also equal to theta. The corresponding angles means if any two parallel lines are intersected by one of the line, the angles made by these two positions are known as what? Corresponding angles, and both the corresponding angles are equals to each other. So it means instead of finding the angle between these two lines, we need to find the angle between these two vectors, because angle between these two vectors is equal to angle between these two lines. Corresponding angles are equals to each other. Therefore, this theta should be equal to angle between two vectors. And already we know that angle between two vectors, suppose this is a vector and this one is a b vector. So a vector and b vector, and theta is the angle between a vector and b vector, and angle between these two vectors is cos theta is equals to a vector dot b vector divided by magnitude of a vector into magnitude of b vector. So here angle between two lines is nothing but theta, and theta is the angle between two vectors b1 and b2 vector. Therefore, angle between these two vectors b1 and b2 is obtained by the formula cos theta is equals to a vector is similar to b1 vector and b vector is similar to b2 vector. So therefore cos theta is equals to b1 vector dot b2 vector divided by magnitude of b1 vector into magnitude of b2 vector. And one more thing you need to observe here, an angle can be, a line can be extended in both the direction. So it means if this is a angle theta, then this angle should be equal to pi minus theta. I hope all of you understanding. And this angle also equals to theta because from the vertically opposite angles. ಶೃಂಗಾಭಿಮುಖ ಕೋನಗಳು ಅಂತ ಹೇಳ್ತಾರೆ ನೋಡಿ. So for that, here we have two different sets of angles, but we need an acute angle. For that, for the angle between two lines formula, we need to use the modulus. We need to use the modulus. Therefore, the formula to find the angle between two lines is cos theta is equals to modulus of b1 vector dot b2 vector divided by magnitude of b1 vector into magnitude of b2 vector, where b1 vector is parallel vector of the first line, b2 vector is parallel vector of the second line. So this is the angle between these two lines when their vector equations are given. Instead of giving the vector equation, if suppose he has given its Cartesian equation, let's see. Suppose the Cartesian equations of the first line, let Cartesian equations of first and second lines are, first equation is x minus x1 divided by a1 equal to y minus y1 divided by b1 equal to z minus z1 divided by c1, and the Cartesian equation of the second line is, see here, x minus x1 by a1 equal to y minus y1 by b1 equal to z minus z1 by c1 is the Cartesian equation of first line, where x1, y1, z1 is the coordinates of the point through which this first line is passing, and a1, b1, c1 are the direction ratios of b1 vector, and x, y, z are the coordinates of general point on the first line. Similarly, the Cartesian equation of the second line is x minus x2 divided by a2 equal to y minus y2 divided by b2 equal to z minus z2 divided by c2. So observe here, x, y, z are the coordinates of the general point on the second line, and a2, b2, c2 are the direction ratios of the b2 vector which is parallel to the second line. Now see here, to identify the angle between these two lines when their Cartesian equations are given, just observe here, in this first equation, the direction ratios of the parallel vector b1 vector is a1, b1, c1. It means this b1 vector in component form is a1i plus b1j plus c1k. Similarly, the component form of the b2 vector whose direction ratios are a2, b2, c2, then definitely b2 vector is a2i plus b2j plus c2k. Now just substitute these two vectors, b1 vector and b2 vector, in the angle between two vectors, that is cos theta. Just substitute the b1 vector and b2 vector in this first equation, that is angle between two vectors cos theta formula. So observe here, cos theta is equals to, I am going to using these two vectors in cos theta. So cos theta is equal to first thing modulus of b1 vector. B1 vector is a1i plus b1j plus c1k dot b2 vector is a2i plus b2j plus c2k divide by magnitude of the b1 vector is equal to what? Square of the I coefficient, that is a1 square, plus square of j coefficient, that is b1 square, plus c1 square. Similarly, the magnitude of b2 vector is square of I coefficient a2 square plus b2 square plus c2 square. I hope all of you understanding. Hence cos theta is equal to, hence cos theta is equals to, see here, cos theta is equals to modulus of, so this is a dot product of a1i plus b1j plus c1k, a2i plus b2j plus c2k, and we know that dot product of any two vectors is obtained by multiplying the coefficients of I with I, j with j, and k with k. It means dot product of these two vectors a1i dot a2i is equals to a1 a2 because I dot I equals to 1 plus b1 b2 and j dot j is also 1 plus c1 c2 and k dot k is also equals to 1. Divide by square root of a1 square plus b1 square plus c1 square into square root of a2 square plus b2 square plus c2 square. And the third concept is shortest distance between two lines. Shortest distance between two lines. So from this concept you are going to get 3 more questions in your annual examination. So for your syllabus we have two cases to identify the shortest distance between the lines. So first case is shortest distance between two skew lines. Shortest distance between two skew lines. So skew lines is nothing but the lines which are non-parallel, and non-intersecting and non-coplanar. Such type of lines are known as skew lines. See here, suppose this is the first line and this one is the second line. If these two are like this, definitely these two lines are parallel. And suppose this line moves in this direction and this line moves in this direction, so a line can extend in both the direction. Definitely these two lines intersect at a certain point. Here first line hinge move ala karta, second line hinge move ala karta. So definitely if I extend this line towards in this direction, definitely these two lines are intersecting. But suppose this is the first line and this moves in this direction, and this is the second line and this moves in forward direction. So definitely observe these two lines. These two lines are non-parallel and never intersecting. So these two lines are known as what? Skew lines. So we need to find the distance between two skew lines. And the second case is distance between two parallel lines. What is the second case? Distance between two parallel lines. Distance between two parallel lines. Now observe here. So first case is what? Distance between two skew lines. See here, suppose this is the first line. And this one is the second line. See here, e line first line hinge move alakatla forward direction daga, e line hinge move alakatla. So this is a 3D figure, we can't show in a plane. So that's why, so just feel it. This first line moves in this direction and second line moves in this direction. It means they never intersect and they never parallel. So therefore these two lines are what? Skew lines. And we need to identify the distance between these two lines. So distance between these two lines is nothing but perpendicular distance between the both the lines. Distance between or shortest distance between or perpendicular distance between, all these three terms are same. He may ask the shortest distance between the lines, or he may ask the distance between the lines, or he also given find the perpendicular distance between the lines. So all these terms are same thing. So shortest distance between any two lines is always what? Their perpendicular distance. Between them. Now see here, suppose this first line passes through the point P, and second line passes through the point Q, and position vector of the point P is a1 vector and position vector of the point Q is a2 vector. And definitely for second line we have one of the parallel vector which is b2 vector, and for the first line also we have one of the parallel vector, that is b1 vector. I hope all of you understanding. I hope all of you understanding. Now see here, we need to identify the distance between these two lines. Let the shortest distance between these two lines is D. That is what? AB. So we need to identify the D here. We need to identify the D here. And the value of D is equals to, value of D is nothing but shortest distance between the lines. First and second line is equals to, the shortest distance between the two lines L1 and L2 are first and second, you may call anything. The shortest distance between these two lines is equal to D. D is distance, so distance is always positive, that's why we need to take the modulus. And then formula is A2 vector minus A1 vector dot B1 vector cross B2 vector divided by magnitude of B1 vector cross B2 vector. So this is a formula to find the shortest distance between the skew lines, where A1 vector is position vector of the point through which first line is passing, and A2 vector is the position vector of the point through which the second line passing, and B1 vector is parallel vector of the first line, and B2 vector is parallel vector of the second line. So this is what shortest distance between two skew lines. Now what? Shortest distance between the two parallel lines. The formula to find the shortest distance between two parallel lines. Now see here, parallel in the sense they maintain a constant distance throughout all the points over it. That is nothing. Suppose this is the first line and this one is the second line. So definitely these two lines are parallel, and distance between these two lines is nothing but their perpendicular distance or perpendicular distance between them. Perpendicular distance between them. Let's say that perpendicular distance between first and second line is D. And one more thing, let the first line passes through the point P, whose position vector is A1 vector, and second line is passes through the point Q, whose position vector is A2 vector. And we need to identify the D. D is nothing but AB. So we need to identify the perpendicular distance AB or D. So see here, these two lines are parallel. If they are parallel, definitely the vector which is parallel to the first line, definitely parallel to second line. So if B vector is parallel to first line is parallel to second line, it means B vector is also parallel to second line. So it means if they are parallel lines, we have only one parallel vector. Therefore, the equation of this first line is R vector is equals to A1 vector plus lambda times of B vector, and equation of second line is R vector is equals to A2 vector plus mu times of B vector. But for the skew lines, we have two different parallel vectors for first line, second line. So it means the equation of this first line is R vector is equals to A1 vector plus lambda times of B1 vector, and equation of this second line is R vector is equals to A2 vector plus mu times of B2 vector. So it means we can easily identify the given lines whether they are skew lines or whether they are parallel lines. If the direction vectors given in both the lines are different, it means they are skew lines. If the direction vectors are given in both the lines are same, it means they are parallel lines. I hope all of you understood. Now the formula to find the distance between two parallel lines, that is what? D. D is nothing but perpendicular distance between them. It is nothing but distance is always positive. So modulus of B vector cross B vector is parallel vector to both the lines cross A2 vector minus A1 vector divided by magnitude of B vector is the formula to find the shortest distance between two parallel lines, where B vector is parallel vector of both the lines and A1 vector is position vector of the point through which the first line is passing, and A2 vector is position vector of the point through which the second line is passing. I hope all of you understood this entire introduction part for the exercise 11.2. So in my next video, I am going to solve the problems in exercise 11.2.